Okay, can we get started? Let's
Sounds
start
good.
with company updates. I see a bunch of orders for $20.
Yeah, the green boxes are really moving. We sold 4 last week. We have 3 outstanding orders right now that we're just waiting on wires for. So yeah, they're moving as fast as we can build them right now. We're working on expanding build capacity. We have all the cases built. They're all sitting there. We got like 40 cases sitting there that we just need to put the stuff in. But it's shared resources with Commas production. And but yeah, no, we're definitely keeping up with orders, and I'd like to get ahead to the point that we send the mailing list. But if we're selling 4 a week, we're making so much money.
Great. Do you have any red in inventory?
We have 1.
Okay.
We have 1 red in inventory, and I'll vaguely mention it here since there's not that many people in here right now. Once that red sells, there might be a new red.
Great.
Yeah, no, we have red V2 coming. With the new cards.
Cool.
Yeah, that and just continue to work on the AMD contract. I think when you get here, we really need to start coming up with timelines and thinking about like breaking everything down into what tasks need to be done. Yeah,
sounds good. Cool. You want to also talk about the things I've been working on? Let's reduce into.
Yeah, so the main thing that I did last week, the main thing that I actually finished that I'm pretty happy with, is define reg now behaves the same as define local and define global. So we used to call it define ACC, which had different semantics, but there's no reason for this at all. So it's now define reg, but you could also, there's no reason that your accumulator has to be in registers. You could also put your accumulator in locals or your accumulator in globals. So now that it's all unified, that's pretty nice. The other advantage to doing this is we used to have define reg also used to have this initializer semantics that was always kind of actually I can probably delete. There's probably a whole bunch of rules that I can just delete now too that specify the placement of define reg at the top of a block. That's all fixed. It now is just the natural topo sort now works, and you can just put define reg where it should be inside the loop nest. And actually, define reg is now always at the top. And instead of having this special initializer semantic, it just uses a store. So it uses a normal store to store the 0, and then it accumulates in the register, and then it stores. So some big cleanups there. And then the other thing that I've been working on really for the last month is, so I can now output kernel 3 at the UOP layer. So by writing the UOPs out manually, I can output kernel 3 from Seb's fast matmls on 7900, and this is using locals.
Can you put a link somewhere?
Yeah, so this is from the Seb blog post, the deep dive into matrix optimizations. So I now have effectively the same thing as kernel 3 being outputted by manual UOPs, and I'm almost there with high level UOPs outputting it. The only thing that the key insight, the key thing that it's still missing is when you have a barrier instruction, you can reorder the locals however you want. So you can rebind the locals to different groups. And we used to have.
So there are multiple kernels in the link you gave. So you pick kernels because 1 and 2 we can already do.
1 and 2 are kind of trivial. Kernel 3 is the first one that there's 2 main tricks missing from kernel 3. One, to go from kernel 3 to kernel 5 is the double buffering. And I have to work to make sure that we can support the double buffering. And then to go from kernel 5 to kernel 8, they're diving down into the assembly. But I don't actually think you have to. I think that if you just did a beam search on kernel 5, you'd get kernel 8 levels of performance.
Okay. That makes sense.
Yeah, so I think that the only other like missing trick is the double buffering. So to figure out how to support that, I have to clean up this high-level UOP semantic thing, and then figure out how to get automated rules to generate them. But like it's looking very similar now to it's looking more and more similar to how like Halide's doing it and how TVM is doing it, where you can create these range variables and then put these range variables in. I'm just trying to work out what the cleanest way to do it is, but like one way to think about it is so I'm really trying to also unify whatever we do for the like overworld ranges. There shouldn't be anything special really about kernel boundaries. There shouldn't really be any distinction between like the scheduler and the optimizer because they're really the same thing. Like we have this thing called opt, which has like kernel.py and heuristic and all that stuff, and then we have this thing called scheduler, which groups things into kernels. But you're effectively doing the same thing. You're assigning buffers to different places, and yeah, we need to like unify them. You could imagine, for example, if you have like an entire model, you could pull the batch dimension out. Like you can pull the batch dimension out of the entire model, putting the range all the way at the beginning, and then having the final store be the only one that actually outputs on the batch dimension. And then whenever you have a long range like that, you can also reinsert that range at any place locally, depending on how you want to trade off memory and like compute order. So yeah, I mean, I also want to like I want to make sure that when I do this, I capture all of these things, even like because I don't want to design another thing that only goes up to like 2018 levels of optimization, which is kind of what we did the first time. So what people are playing with now are these like mega kernels, these single kernels that can run LLMs. And they're using like this fancy dispatcher logic to do it in their thing, but I don't think you need any of this. I think if we do it right, we could actually like so you have like Barrier, and Barrier will synchronize all the locals across all your groups. But you can also make a global barrier. You can just use atomics and do this. So yeah, I want to unify that. I want to unify the idea of a barrier, a global barrier, and then registers obviously have no barrier. But yeah, and I've been spending a long time on this, but this I want to make sure that whatever I write for this, it can output everything in the fastest 2025 kernels. And then we have a complete.
Yeah, that makes sense.
Yeah, I've been looking a lot more into how TVM does this, and then there's this thing TileLang, which is just like built on top of TVM. You do end up reinventing most of TVM's concepts, which is kind of upsetting, but
I mean, that kind of makes sense. It's like, how many primitives can you have? It's not that many.
yeah. There's the primitives, and then there's this whole concept of like binding. So like we would just implicitly bind things to globals and locals, but there's a lot of different ways you can do that, especially with locals.
Mm-hmm.
So the way that I want to do it instead, the way that I was thinking about it last night after I wrote this stuff up is like, what you want to do is you want to pull the global out of the whole graph. Like you can remove the globals from each of the shape, and then the whole graph is just this inner thing, which doesn't have the globals in it anymore. And then you can work on locals and pull those out of the graph, or maybe out of different chunks of the graph. And then you're left with registers, and then that's it. But yeah, so progress. I don't know. I mean, I think that this is my main contribution. This is going to be my main contribution to the AMD contract, which is, yeah, going to be, I'm going to make the flash attention kernel and the gem faster than anything else on that card.
Great. Okay. Are you introducing any new UOPs or removing any UOP?
I think overall UOPs have been removed. Well, so I've removed assign. There's no more assign. There's still assign in the overworld, and I think we actually want to keep it there. But there's no more assign in graphs anymore. So like in kernels. Kernels used to have both assign and store. There's no more assign. So I've removed that. I've simplified define reg and unified it with the others. Yeah, so I think overall this has been UOP reduction. Oh, and then I'm playing with how to... We may want to change expand. So if you think about reduce as it takes dimensions off of the end and reduces on them, you can think of expand as the inverse of that. And like our current expand isn't that. Our current expand looks a lot more like our old reduce. So we may want to switch expand to something that just inserts copies at the end. And then we can remove ones from the graph entirely. From the shapes.
Yeah, I think even for the tensor front end, we really want the method to add one len expand. This pattern has occurred many times in tensor.py, and it's usually pretty awkward.
Yes. So think about this instead. Think about the primitive being, so you have something that's like 10, 10. And then the new expand, you put in a shape like 10, 10, 10, and the last 10 on the end has stride 0. And then if you want to put that in a different place, you permute it afterward.
Why not just put the axis you want to insert stride 0 and how big you want that to be?
Because why put it at an axis when you can do a permute afterward?
Because I don't understand.
Well, I mean,
like,
it just makes...
Why forcing into the end?
I mean, we force the reduce axis to the end. It's the same thing.
Not in tensor.py.
Yes, in tensor.py. Tensor.py under the hood, when you call .r, it does permutes to force the reduce to the end.
No, but not when you are still operating on the tensor level.
Well, under the hood, yes. So when you are constructing the reduce UOP at the tensor level, it's actually moving the... Yeah, I mean, we can keep whatever syntactic sugar you want at the tensor level. I'm not saying we're going to change what the expand function does. The expand function under the hood will just insert this like, I don't know, like whatever, like copy, not copy, but like what is that called? You know, like alias copy and then permute. I think it's much cleaner than having to specify axes as well as a shape.
Yeah, sure. I mean, in the internal method, do whatever. That's straightforward.
Yeah. No, I'm just saying like what the internal, like what the movement UOPs are going to be. The movement UOP is going to be something that inserts expanded dimensions at the end and then permutes them to put them wherever you want them. And then this functions as the inverse of reduce. And then probably it also makes
to happen after the reduce shifting refactor.
Removing the ones from reduce. Yeah, I don't know why that doesn't work. I've tried it a few times. It just doesn't work. So
no, there are. I don't know. I was looking at some of the const device view left whatever stuff, and
yeah,
get contraction get underscore contraction underscore with underscore reduce, something like that.
Yeah, I mean, these things, we can rewrite those methods to be a lot simpler now that all the dimensions are compact. Like, yeah. Because we have like all the normal dimensions followed by all the reduced dimensions. Instead of having a special get contraction with reduce, we could just have basically 2 get contractions.
Yeah.
There's a lot of things that are just a lot simpler to specify once you realize that these reduced dimensions are like at the end and added. Well, the dimensions are removed by the reduce, and then I want to make this like shape tracker inverse, which adds the dimensions on the other end. And then also I kind of want to write some like shape tracker. I want to write some like UOP algebra to maybe clean things up at the movement op level instead of going straight to views, because the movement ops have a lot of information that we throw away when we go to views.
Like what?
Well, so like if you have a view, how expanded is the view? Like, given a view, can you figure out how much of the original tensor is accessed?
Isn't that the S max on your index?
Well, yeah, but that's only going to give you a max. That doesn't tell you about like how many elements are accessed.
Oh, what do you mean?
You see what I mean?
No.
So it can definitely tell you the max index, but what if that thing is like stride pen or something, right? Like the max index could be 100, but you could actually only be accessing 0, 10, 20, 30, 40, so on.
Okay, I don't know. Maybe I need an example.
It's just a lot easier. I mean, with all of these things, like when we do gradients or when we do multi, it's a lot easier to reason about the movement UOPs than it is to reason about views. Because we can reason about each movement UOP. Like the movement UOPs are simple. It's really easy to reason about. Oh, this is a shrink. This is a pad. Yeah. So yeah, I think like more might do some more focus there when I change these around to be the I don't know. I gotta think of the right name for it. The name for like insert more dimensions at the end that are copies.
Okay. I think it's pretty good at naming stuff.
Yeah. I'll ask ChatGPT about this. But yeah, if we switch the expand to this and we switch the reduce to remove the ones, these graphs will also just be easier to read. Like just a whole lot easier to understand. It's like, oh, cool, I'm sticking those there, and then we can like push permutes around a bit. Yeah, and end up with some like very simple. Oh, I understand what the movement patterns are here. Instead of like this arbitrary view, which is like, oh, that's cool, but
I don't know. I mean, yeah, maybe.
I mean, going to view like strictly destroys information.
Yeah, because that's the minimum information you need. That's why you want view to be merged.
Yeah, and then like once you go to view, it's like, again, what's the gradient of a view?
You know, maybe there are magic methods to get to this. Anyway, that's too far digressed.
Yeah. Again, if there's magic, I don't know.
No,
If there
I
is
mean, you keep a map between movement up to view, right?
no,
Relative your
I
movement up.
I don't do that, and there's
That's your
all
data
sorts of
set.
problems. Like, yeah, we have the function to invert it, but I don't know. I think that those transformations are like NP, and like you can do them, but yeah.
Okay. Anyway. Cool. Okay, sounds good. Llama. I don't know. What do you have? Any update?
I have a bin.idx loader, so we can load those. Yeah, I mean, we can load all the sequences from the val set. They're all different lengths, which is annoying.
Yes, I understand.
Yeah. The Nemo code is still really hard to read. So it turns out that they have GPT dataset in the Nemo code base, but that's not actually the one that they use because there's one in Megatron Core that's like split out. And then they import it dynamically, so if you just like, you can't really follow where it goes.
I would just like run it and then write a test to make sure I'm getting something.
So the problem to run that is you need to mark all the actual codes to their device and setup, and I mark all those to get something. It's very ugly.
No, I just traced the code, and I think I have a pretty good understanding of how Nemo is doing the data loading now.
Anyway,
Uh,
we will figure this out after me flying there, and before you are gone, we will figure
Yeah.
something out. Yeah, I think this is a problem with this benchmark. It really is not a very good reference implementation, air quote on implementation.
Yeah. Very less information.
Does Google have a better one?
No,
Supposedly
Google
Google's is
also
like
didn't
not
submit.
correct either.
So
Oh.
Google's submission is lack of the actual implementation. I'm not sure why. So everyone in the current round of submission is just calling that script.
I see. And then did they mock all that? I mean, Google's using TPUs, right? Did they mock all the NVIDIA
No,
stuff?
so Google submission, their audit submission, the first step is we convert all the examples to TF records stored in this internal place
Mm.
without telling you how they convert.
Isn't that against the rules?
No, so they didn't submit. They withdrew the submission.
Oh, I see. But so they didn't open source the code.
No. And even if you look into their like original submission, the private repo, there's nothing.
Well, but sounds like you have something that works.
Yeah.
Yeah, so I think our best bet is trying to. That's what I did before. Understand what's like try to code their thing on whatever GPU as long as it runs and see what's the behavior and try to do that behavior.
The other thing is there's like, at least the data set has a bunch of extra data that isn't used, as far as I can tell.
Okay, I don't know. We will figure this out. It's not very useful to discuss like in this meeting.
Yeah, I mean, we got to get a timeline for when we're training. We got to get 8B training.
Yeah. Yeah, it's Llama. We can move on to this.
I merged a new view disassembly in this yesterday. I think this week I'm gonna add the RDNA3 like instruction timings to the side.
Cool. Is the metal one working now? Do I see metal performance counters?
It is in a branch.
It's in a branch.
You
Okay.
have Xcode. Yeah, you have to like install the Xcode from the App Store.
No, why do I need Xcode?
I'm sorry. There's absolutely no way. They don't ship the binary as a standalone. You have to install.
Do I really need this binary? What's it doing?
It's recording GPU counters, I guess. AMD is much
Yeah.
nicer. AMD actually documents these stuff and open sources them, but Metal is
For AMD, I mean, we're just setting the registers to do the SQGT logging, but yeah, we should figure out what this is and avoid Xcode. I do have Xcode. So what's this branch called?
Metal Trace is on my
It's a one in general.
yeah.
Got it.
Yeah.
Oh, it's on your
You can fetch this hash. It will go there.
got it.
Yeah.
Let's see.
I will test on the AMD UOP. So it's a big one. Small ones just show like zeros.
All right, so I'm on the branch. Do I have to put anything beside viz equals 1?
Profile equals 2.
Oh, profile equals 2. Oh.
More like
Cannot find matching template name GPU counter.
Great, it doesn't work on your branch.
I have Xcode.
Could not find template GPU counter. So it did fetch.
I don't have that support instruments GPU. I don't have instruments.
Oh, you're on like. No such problem.
I'm on Sonoma 1473.
Do you have instruments like the app?
I do.
Oh, it doesn't make the directory. That's absurd.
Yeah. We need to figure out how to make this stuff more robust. Ideally, we need to figure out what that. Maybe UVN. Maybe you have some ideas about how Apple's actually doing this. No
if
idea.
you really want to do it, just make that directory, that templates directory, and test it.
All right. So I make this directory. All right. Do I need sudo to make that directory? No, it didn't look like it. All right. All right. Profile equals 2 viz. I'd start recording with the. Okay. Parsing time info, parsing GPU counter info, parsing GPU counter value. Okay. Took a while, but whoa. All right. We got some stuff.
Yes.
This is box tiny when I click on it. Oh, I'm using 99% of my SRAM. So when I click on this kernel, is this an average of the runs or is this one run?
Do you see like run 1 out of 3, etc.? Like it shows at the top.
Oh no, I guess there's only one run here. If I put the test name twice, does it run it twice? Alright, cool, it ran the test twice. Oh, this is mad slow too.
It is mad slow, I agree.
Oh, I see. Yeah, okay. Run 1 of 2, run 2 of 2. Okay, I see. I can scroll down here.
We'll get a screenshot.
Yeah, I'll post a screenshot. Yeah, okay, cool. I don't know. Maybe we shouldn't spend too much time on Metal. And we should just make sure that this works for AMD. AMD is the real place we need this. And yeah, I think the instruction level profiling stuff would be cool too.
I think I'm gonna do that on the fly. Like the way I generate the disassembly on the fly, just execute the kernel, sample it.
Yeah, I mean it would just be great. It would make the workflow so much better if we could just we're gonna be probably in about a week or two. I'm gonna be ready to start really just optimizing the gem and to see where all the hotspots are would be great.
Right? Yeah. Everybody.
I mean, yeah, eventually we'll be able to like put this, we'll be able to guide, I want to be able to guide the search with this stuff.
Yeah.
I think that that's a huge advantage. I mean, this is a way that we can beat like TVM search. None of these searches are profiler guided. Aside from just measuring the time. But if we could look and we could figure out like, I mean, even asking like little questions, like there's like a maximum number of memory accesses that you can have in flight. And eventually you're going to hit that and it's going to stall when you try to add one more. So then like the whatever optimizer we have should be able to look at that and be like, okay, well, I should stick some ALU operations in there because they're free. Like that's eventually where we'll get to with this stuff. But cool. Yeah, I think focusing on AMD and hopefully making it so we can. I guess you're always going to need some kind of extra flag.
For Metal, because it's sampling and requires Xcode install, I'm putting it by flag. But for SQTT, because I'm generating on the fly, I'll just put it in this one. To create a disassembly.
I don't think that's going to work. I think SQTT uses a ton of GPU RAM.
Oh, I mean, like not enabling SQTT during the run, sampling it later, asking for the sample later.
Oh, like rerunning the kernel.
Mhm.
Oh, interesting.
Just want instruction level time, right? You don't want like full GPU state.
Yeah, I
You can
guess.
just eventually like rerun the entire state.
Yeah, I mean, the only problem with that is like if you recreate the buffers, everything's not going to be in the same like L2 position. Right? Like you don't know which buffers are going to be hot in your L2. Either way, I think that there's a lot to do here. Yeah, getting to the point where we can view like just the infrastructure to view an annotated disassembly. Oh well, yeah, okay, yeah. I think there's probably some like lightweight stuff we can get. Anything we can get that's like lightweight should be in Visible 1. Like yeah, if we can just read performance counters. But if we need actual tracing, that's probably going to have to be behind a flag.
Yeah, instruction level tracing is pretty heavy. So
Yeah.
okay, yeah, cool. I can merge metal. I merged all the general stuff to master already. The diff is just like standalone. Metal
Yeah, I
tracing
mean
stuff.
it's yeah, as long as it's not going to like interfere with anything behind a let me read the diff and see how crazy it is. What is like I see like start XC trace. Oh, I see. Oh yeah, I wouldn't put. Why do you have that if statement inside start XC trace?
So there's one XC trace process per metal GPU.
No, I get it, but like you have like a call to a function called
Yeah,
start.
hoist your ifs.
Start. You have a
Oh,
call to
okay.
a function called start XC trace. Yeah, that if should be that if should always be outside, right? Like the function shouldn't gate it. The gate should be. Yeah, I see. Okay, so a bunch of terrible OS systems. RMRF. Don't do that. Don't do that. Use pathlib. And then what's here? This is biz stuff. Yeah. Cool. Yeah, a few comments on that, but looks good.
Yeah, some people will reverse this one.
Yeah. Yeah, no, I think no rush on the metal one. The AMD one's the most important. But it's always good to support two.
Okay. Anything else?
No, that's what I'm like.
Okay, let's move on to drivers.
Yeah, so I merged the CPU copies. So they are now the part of the HCQ graph, and that's like the pinned memory, and they're fast. Yeah, so I'm going to finish CPU uploading this week and profile it. So to see that everything is fine, not overlapping.
Great. So is there any CPU threading support on the roadmap?
Yeah, I thought about that. I mean, I have a branch, but currently it's not merged, basically because of the overhead. Like, yeah, it's like 11 microseconds compared to the master. So launching kernels. So, yeah.
So like, I haven't kept up to date. I haven't read your changes to HCQ, but like the more I look at HCQ, I think that like eventually everything's going to become HCQ. Like, what can't be HCQ?
Yeah, I think. Yeah, I also thought about that. That currently we have like HCQs, like a lot of abstractions already, and maybe it would be a good idea to unify them, like with device.
Yeah,
Because
I think
but
there's a lot
I
of.
don't know anymore.
I feel there's a lot of stuff that can be refactored there. I feel that this is like a big place where we're spending a lot of lines on these almost replicated abstractions. Like we have like device and HCQ device. We have buffer and HCQ buffer. Yeah, like what would it take to unify these into, to very carefully unify these into one very clean one? Also, did we fix the issues with on the MI350? Do we fix the beam issues?
I think no. So I haven't looked into that. I think it was kernel problems.
I think that
runtime.
we got to make sure that gets fixed. I think that's high priority. You mean just it's generating bad kernels, or it's like not setting like the shared memory something right?
No, I think it's bad kernels. I think we discussed this previous time, or maybe I misunderstood that.
Oh, you mean like it's accessing out of bounds memory?
Okay, I need to check. I think False Parrot mentioned that.
Don't the page file addresses maybe don't seem like that? I'm not sure.
I think fixing this is top priority, and then also how is getting our 5090 driver and CI going?
It's yeah, I just tried to replicate like the segfault. I know it's strange. It's like happening in Python during imports, so I'm not sure. Like I just catch it only one time, so no, I can. So I just don't want it to break CI because I think like sometimes it's still possible to reproduce the segfault, and I'm not sure why.
What we should do is we should get 2 of the H machines on CI if you wanna do that. Yeah. Yeah. So most parallel get 2 of the H machines on CI, and then we can start. I mean, even if they fail sometimes, I think we just gotta get something stood up with these 5090 drivers. And yeah, it should check. So we should test both on those machines. We should test, like, think of them as like driver test CI. We should test the 5090, and we should test they all have 9070 XTs in them as well. So we should just have some basic stuff which tests the drivers. There should be no drivers installed on those computers, or at least never inserted. Yeah, we gotta get that stuff into CI.
We already don't insert on thread.
Yeah. Yeah, we can leave it inserted on the greens with the 4090s, but with the 5090s, let's get this stuff on our driver.
Yes, I think once machine's up, I think it's ready.
Cool. Wanna do that, Jeff?
Yeah.
Great. And then I think your main project is just going to be benchmarking the optimizer, the offloaded optimizer, on the MI350 machines, and figuring out what it's going to take to make it faster. If the copies are fast now, that's good. And then seeing, we're probably going to have to do some multi-threaded stuff on CPU. Because I don't think the CPU, from a single thread, there's no way the CPU gets all of its RAM bandwidth. Like, there's no way to run Atom from a single thread and get anywhere near the copy out performance.
Yeah.
I guess you don't need all the RAM bandwidth. You just need no, but it's actually the copy out of all the GPUs. Yeah, so you need like an Atom kernel on the CPU, which is capable of processing 400 gigabytes per second.
Mm-hmm.
Which, those are the CPUs in those new machines are incredible. We're also going to get any progress on that. I think we have a bunch of those cards coming. We're going to put some 16 terabyte RAID arrays in both of those machines. We should figure out how to buy those drives in bulk.
Yeah, just ordering now. Oh, and I don't think the card is here.
Yeah, there's some thread about that. Let's forget with the purchase order and yeah. So we're gonna put some massive RAID arrays in those computers, and then the other thing that I want to benchmark is copying from. So the RAID arrays should be able to get about 100 gigabytes per second, and we should be able to copy to the GPUs at that full speed. So the load of the 405B, so 405B at FP16 is going to be 900 gigabytes. So yeah, I want to be able to load that in like 10 seconds. Actually, yeah, how are we doing right now? What's our copy speed from the RAID array on a tiny box to the GPU?
On the tiny, I think it's about like 10 gigs a second.
Why isn't it 20?
Yeah, I mean, for the disk, we're still limited by the CPU.
What do you mean we're limited by the CPU?
Basically, because we do 2 copies, we just. But actually, no, I need to check that. Maybe it's better now. But yeah, actually, because we go through the system memory, it's still. No, we don't do any amount copies on CPU, but yeah.
All right, so I'm on Tiny R9 and I'm running Python 3 examples Llama 3. Let's see what our time is. Oh, well, actually that one's a little unfair because it's the 1B, right? So let's do size 8B. So I'm running this. How fast should that load the thing? I'm getting 2.19 gigabytes per second.
Yeah, but okay, I can measure the roll speed. Actually, that's because of the Python as well.
What's a good way to measure the speed then?
Oh, there was a test that did this?
I mean, but like that's the one we really care about, right? Like I would love to see that loaded in under a second. Yeah, I think some of it is that we're realizing them individually. My Almo a little better. That's gonna take forever. But yeah, no, we should make that fast. Make the whole Llama 3 thing fast. There's a flag to the loader to not have things realize individually if you're saying that that's what's slow.
Yeah, okay, I see. We have actually external benchmark bscroll that should measure the roll speed.
Also, is this one with some Prometheus stuff?
which community stuff?
I don't know if it's this example, but some Llama code, some Llama model has permuted tensor on the disk. So it's calling like permute as part of a loading process.
I ran external benchmark disk raw and it's seg faulted. And now it's running and it's very slow.
Okay, let's get these fixed.
Yeah. Oh, this is brutally slow.
Just post the comments.
So this is what I got from external benchmark disk raw. I first got a seg fault, and then I got a copy at 0.5 gigabytes per second. And then I ran it again, and I got one at 1.4 gigabytes per second. Yeah, Niljan, any idea why these are so slow?
Yeah, because CPU doesn't. I mean, just copy to GPU. Like the CPU doesn't support that. I mean, CPU doesn't support fast copies from disk.
Why is it not? Oh, I see. Why is it not copying to GPU? Oh, failed to take. Oh, is someone on this machine? No. Oh, I see. This process has a lock. That's annoying. Okay. Okay. So this is better. Now I'm getting 9.7, 9.8. All right. So why is it not 20?
Yeah, okay, I'll take a look into this.
I'm trying it with DD right now and seeing what I can get. Yeah, DD only gives me 9.9 also.
Yeah, I found it's actually very hard to saturate this without multiple threads copying.
Got multiple threads copying.
Like on this array, I had to use 16 to actually get.
Oh, you had to use 16 threads to get the
Yeah.
full. Okay, cool. So we're gonna have to support multi-threaded. I mean, so this is going through system RAM still.
Yeah,
There's no way to tell the disk the DMA to the GPU.
I mean, with IORink, I don't think so. Or maybe, I know, maybe we can use this DMA buffer thing, but not for AM, for now, at least.
Not for AM. Yeah, no, I know we talked about this. We'll have to write our own NVMe driver if we want to do that.
Yeah.
But okay, cool. I mean, at least like 9 point something's not terrible.
12 now.
Yeah, well, that one was 12, but that's good some RAM.
Yeah.
Cool.
Good. Let's move on to Cloud and hash. Oh, I did a bunch of hash pulling up and stuff by inserting some kernelize and don't use all the const in C tensor. For now, at least you're hashing 1 MB rounds. I think what's happening is you cannot have an internal representation that grows in the size of your data. That simply won't work. You could argue that one meg is a const, but it's too big of a const for our UART and device rewrite. So for now, at least it runs and it's value is correct compared to the hashing function.
Good.
Your thoughts on this?
I mean, I merged the InfiniBand P2P one. That was fine. I was messaging you, Vian, and he said that something regressed. Where it might be slower. At least for beautiful MNIS, but that's pretty small. The overhead is like 3x.
I see. I mean, we should just test this and pay out the bounty if it's
Yeah.
if it's good.
I think, yeah.
Yeah. I mean, if we're training on.
Yeah. I'll start a run today, and then if it's
Cool.
good.
Yeah, sounds good. I mean, we should also on next ML perf. I want to get I mean, I think our real goal for next ML perf is going to be if we can get a 405B on a single machine, and we can get a multi-machine anything else.
Okay.
That's pretty good.
Is Bert still in the next one?
Yes.
Okay.
Sweet.
Yeah, then.
Oh, I think so.
What about the ResNet
I
part?
could toss.
Yeah, Bird is fine. If
Bert is fine.
just Bird is fine. If it's some weird,
Just Bert is fine.
yeah, we're cool paying out the bounty for just Bert. But I do want to figure out what this regression was.
Yeah, so let's close and hash. For Onyx, I would just summarize the bunch of stuff for comma. I think the script issue was fixed. I also added the div equals support for the flag, their favorite flag. So hopefully we are happy now.
Oh, we have dev. We can set the device with dev.
Yes, I
They
support that.
reverted the Tinygrad bump for dev.
Okay.
I don't know if they reapplied it.
Okay. Anyway, it's there. I don't know. I closed that issue and say if anything is wrong, let me know. For Onyx specifically, clean up some parser stuff and like the old parse buffer code clean up, and I think working on more cleanup. Like we get this eventually merged. I also clean up some like type stuff. So generally, just need more cleanups.
Cool.
Yeah.
Yeah. How close do you think we are to that?
I mean, depends on
This week.
quality. Right? If you just want to merge it versus you want it to be clean up then merged, it's different.
Yeah, I mean, I definitely don't want to change the API after we merge it. It depends what you mean by cleanups.
I think API is fine. I mean, if you say this week, then this week it is.
Did we ever figure out what?
Go on.
Did we ever figure out what the seg faults were?
No.
I see. I feel like there's some race condition in disk or something.
Yeah.
Maybe like something's getting closed and it's trying to read
I don't know. That's not a blocker. That's an independent bug anyway.
God.
Okay. Yeah, I mean, it's moving. We move. I think it's very close. It's just like there are some weird test case that's always there. Oh, I also removed strenum thing that was only introduced in 3.11 or 12. So it's not compatible with 3.10. So I removed that, and I think 2 training tests has some D-type issue. I just skipped that because it's fairly minor, but we also want to fix that. And I also add this to the CI, so it should be linked by 3.10. So this won't happen again.
Cool.
In general, more stuff that can make merging Onyx smoother. Onyx, other bounties.
I'm adding a $200 bounty now for Muon Optimizer.
What is a new one?
Muon.
Oh, the Facebook one got merged.
Which Facebook one?
So Torch is going to merge that as in their official repo. There's a PR for that.
Oh, Torch is going to merge Muon.
Yeah.
Oh, and that reminds me, I still haven't looked at the torch, at the beautiful Omnis torch every
Great.
week.
LBC4 one.
HLBC4. I can't believe still that fuse A range isn't equal to 1 yet.
I don't know. No one is working on that.
I mean, it's kind of related to the reduce refactor. It's like so simple when you get down to what it is. I don't know though. Scheduler and CodeGen almost both entirely need to be thrown away and replaced by a new thing. Yeah.
Sounds good. Oh, what's the status for? Do we still have the merge, assign, and store thing? Is that still a thing?
Not really. I kind of did it.
Okay, you figure out that one.
Yeah. I don't know. I paid Cordis like half the bounty. I think I did half of it. I think it's kind of I mean I did the whole like define reg thing, which was really the hard part. The overworld, it actually does mean something different. Assign returns the buffer, whereas store doesn't, and this makes the overworld cleaner. Yeah, so I think like those are like mostly done. The const refactor can still be done.
Yeah, I was staring at that. I did something small on that, so now it's less scope.
Cool.
Tried something with removing ops LLVM.
You removed ops LVM?
Fine. Just to unify it with CPU.
Oh yeah, we should.
Yeah, the device and compiler separation.
Oh yeah, that's a good project.
Not quite that. Just removing ops LLVM and making it like a flag to turn on LLVM compiler.
Yeah. I mean, what we want is like a device can specify multiple compilers. We have a whole bunch of these now. Like AMD has LVM and HIP. CPU has Clang and HIP, Clang and LVM. Yeah, so NVIDIA has PTX and CUDA. So yeah, that should all be. That's like a big refactor that needs to be done. It shouldn't be hard. It should just...
Rocksoft's 200 bounty. Okay, great.
No, first off, your class is like, no, don't give me this shit. Your class is called Atom. You have NumPy. I'm tempted to ban you. Delete that shit. Right?
Yeah.
Do not give me AI crap ever. I don't care if you use an AI, but if I look at it and I'm like, this looks like AI, like you're wasting everybody's time. Please don't do that.
Yeah. Anyway, I was writing Muon, and I was hoping that I can wait until the Torch one got merged so I have a reference. That's how I'd like to test it anyway.
Yeah.
I think the official implementation is not that bad. Fairly clean, and there's a lot of clean implementations of Muon as well.
Yeah, but I mean, it's like the easiest way to maintain.
Yeah.
If we have to install something, we have to install something. We still have to install something we still install like TensorFlow to test Lion or Lamb or whatever.
Yeah.
Go to get rid of that.
Yes, and it's pinged to a much older version because Add9 is deprecated.
Yeah. Maybe we can clean that up.
If someone can find a better way to remove that would be nice.
Yeah. How's the Whisper bounty? stuff on that. Didn't have much time to work on it. Oh, that's from last week.
We don't really have that many bounties. That's like semi-workable. I don't know if that's an issue.
Oh. I mean, it's kind of hard. All of this, like this refactor stuff, is really hard to make bounties.
No, it's easy to make bounty. It's very clear what the end state look like. It's just very hard for people to do it.
Yeah. Maybe. I mean, I've been working on. Maybe we'll be able to have a bunch of bounties once I have this like intermediate UOP syntax. We could just. I don't know, but no one ever does those bounties either. The ones where it's like get the gem to be fast. Flamit kind of does them, but yeah.
Anyway,
HVIC decode is a very doable bounty. $500 for that one. That one's doable. RKNN NPU, $500, very doable. I'll move those ones to the top because they're very doable.
Have you seen the new chip?
What new chip?
Rock chip's newly announced one. It looks pretty good.
No, is it good? What nanometer?
I believe it's 3.
Really?
37.
Wait, there's no way they let China buy a 3 nanometer chip. I don't know. Off topic for the meeting.
okay, great. Oh, my flight got delayed again.
Oh, great.
Okay, hopefully I'll see you later today. I
Cool.
think that's it for this meeting. Thank you all. See you next week.